Hey everyone, my name is Dave Johnston and I'm the director of the Duke Marine Robotics and Remote Sensing Lab. In this video, I want to introduce to you the way that we're using drones in marine science and conservation. That's going to give you kind of some background on our lab. It's going to provide you some information about the applications and issues that we're going to talk about over the coming weeks. And hopefully kind of pique your interest about some of the things that are coming in the future. So stay tuned. Here comes hopefully an introduction to marine science and conservation with drones that you find interesting and valuable. For this talk, I'd like to sort of introduce to everyone where drones kind of fit into our remote sensing capabilities, a little bit about the capabilities of our lab. And then I want to talk about maybe 5 or 6 primary themes that we're going to cover over the next few weeks that range from studying individual animals and their biology and ecology to, thinking about how we can use drones for reconnaissance and surveillance. And then ultimately, for things like, integrative ecology and restoration. I want to briefly touch on automated workflows and then what constrains our use of drones and what might happen in the future and how that may change. So to kick things off, I want to sort of put drones in their place when it comes to our remote sensing capabilities. And you can imagine ecologists working on the ground, making very fine scale measurements. And up to maybe 10 or 15 years ago, we only really had access to remote sensing capabilities from occupied aircraft and satellites in orbit, both of which have limitations in terms of tasking and atmospherics. And so drones kind of fit nicely right in the middle there, right? They're in the spot where we can fly below the clouds and we can do things when we want to. They bring a sense of immediacy that's actually really important. And so drones don't replace these other techniques, but they help fill the gap that hasn't been filled with previous technologies. Now, my lab has been working for the past 5 years or so to develop new methods and new approaches to use drones in marine science and conservation that essentially provide this on-demand remote sensing capability now. In many cases, this allows us to do things very safely, often more affordably, and in many cases providing as good as, if not better, data. Now, some of the stats that you see here were generated for when this recording was made, which is the summer of 2020. But in general, we've been flying quite a bit, over 3,000 flights with almost 800 hours of flight time. And in every, sort of 3-month period of time, we were flying maybe 150 missions across different biomes from polar to temperate to tropical systems. So we've got a lot of experience working on these different kinds of factors. Of course, across the next few weeks, we're going to use a lot of different terminology, and there's a lot of different words out there for what I'm going to probably refer to as drones for the majority of the interactions that we have. But we see acronyms like UAS, UAV, RPAS, which is remotely piloted aircraft systems. There's often a tension between unoccupied and unmanned, and also sometimes tensions between whether or not it's an aircraft system or an aerial vehicle. We tend to use unoccupied aircraft systems because they're aircraft as outlined by the FAA, and we use unoccupied because it's ungendered and captures this complexity because it's a system. So that's the way we approach our official terminology, but we'll mostly refer to them as drones. In our lab, we use a range of drones. We use drones that are driving on the ground and also underwater drones, but we also use different forms of multicopters and fixed wing aircraft and are also now working with transitional aircraft that combine the benefits of both of those to achieve a variety of conservation missions that range from assessing organismal abundance through looking at different kinds of habitats. And I'm going to sort of walk through those things now as we proceed through the video. To start off, I want to kind of introduce the concept that we can use drones very effectively to be able to count animals and assess their distribution. So in this case, we have a drone pilot flying a fixed wing over a colony of seabirds and being able to assess how many there are and what kind of habitats they're making use of. And I have a nice video that establishes that for some seal work that we've done in in Canada, looking at gray seal colonies. In this video, I want to illustrate how we use drones to be able to count and look at the distribution of gray seals. So we're able to hand launch the aircraft and we track its progress through a ground control system that provides information on the path as well as all of the flight details. Some pictures of what the aircraft is generating to be able to identify those organisms. And this little bit of video here just gives you a better context for what that habitat looks like. A lot of sea ice. And this is in the spring in Canada when gray seals are giving birth to their pups. As the aircraft completes its mission, it circles, it detects the appropriate vector to come in for a landing, and then we'll come in on a shallow linear landing and touch down just in the snow adjacent to where we're operating from. So we can take the data from that and then we create orthomosaics that are really helpful for us to be able to do things like count seals and assess their distribution. This is an example orthomosaic of one of those seal colonies, and if you were to zoom in on this picture, every pixel would represent about 2.5 centimeters on the ground, so incredibly high resolution. And I want to show you sort of what that means by zooming in on a video for the island of Muskeget in the Northeast, which is the biggest gray seal colony in the US. As we zoom in, you can start to see different habitat features. And as we zoom in a little bit closer, you'll actually start to see individual seals. As we zoom in a little bit closer, you can tell the difference between adults and pups. So the larger animals that are brown and gray are the adults. The smaller white organisms are the seal pups. And you can actually even tell the difference in terms of their molt stage and sometimes their health. So if we compare these two seals, one looks very flat, and in fact that's the juvenile mortality that we've been able to detect in this drone imagery. As we back out now, can show you an example of what people look like in this. So we're going to zoom back out and then zoom in on this area, and in this case you can see 4 people. There's a person in a yellow raincoat that's writing in a notebook, a person standing beside them with a red jacket on, and then 2 people that are actually doing a health assessment on a seal that are straddling it. We can also back out and take a look at another example where there's some gear piled up on beaches. And if you look closely, we are actually capturing mating behavior of gray seals. Here and down here, we actually see 2 pairs of gray seals mating, which allows us, another opportunity to observe behavior that might be disturbed if we're trying to use different methods, traditional methods, to be able to do these things. And so hopefully this video gives you a sense of what that high resolution imagery can provide you when you're collecting maps of colonies at, around, 2.5 centimeters per pixel resolution. All right, so now let's switch on and talk a little bit about individual sampling and thinking about how we can apply drones to study organismal behavior and body condition and health of different organisms. And the one thing that's really amazing about the use of drones in this context is the immediacy that it provides. And this is a great picture that kind of gets at that point. It's an example of us working in the Antarctic Peninsula region looking for whales. We're able to move through icy conditions. When we spot a whale, within 5 minutes, we're able to launch a drone and be able to then go and assess its body condition through photogrammetry, or potentially study its behavior, surface behavior, or even collect its respiratory vapors to be able to look at respiratory microbiomes and other things. So I have another video that kind of captures that process that I'd like to play now. In this video, we're going to look at the process to launch a drone from a small boat to be able to study humpback behavior in the Antarctic. So here we have our drone pilot, Julian Dale, who's going to hand the aircraft up to me. This gives you a good sense of the kind of locations that we're working in and the conditions. Apologize for you having to look up my nose there briefly. This gives you a sense of what that operation looks like working from a small boat. The aircraft's going to take off, and if you look over my left shoulder on the right-hand side of the screen, you'll actually see a humpback whale that's about to go on a dive. And we're going to move in over that set of animals and take a look at what's happening. So the camera's going to pan down, and what we see is some bubbles coming to the surface, which is evidence of a group of animals bubble net feeding, corralling krill in the center of that bubble net during some coordinated foraging. And in this case, this spiral bubble net is created by 4 animals that are coming to the surface now, as you can see, and then they're going to process those gulps and move on to the next patch. When we get them to the surface and they're clear of the bubbles, we're able to take pictures of them while they're flat at the surface that allow us to be able to measure their length and their widths and conduct things like body condition assessments. But these videos also allow us to be able to study this behavior in more detail. And so we have a little bit of an interesting kind of close-up here where you can see that bubble curtain coming to the surface and 2 animals that are coming to the surface after lunging at depth and then moving on to the next round of foraging. So it gives us a way to be able to quantify those things. Once we're done our observations, the aircraft is brought back and captured by hand, and then we are ready for the next one. So a good example of how we use that in this context. We can take those images, and because we have good information about their altitude, we can make measurements of them and understand their morphometrics and their body condition, which is really a fantastic tool to have. As I said before, we can also look at their behavior, coordinated behavior in terms of bubble net feeding. And these types of drone missions also allow us to work in a sort of integrative ecology collaboration, where putting video tags on whales allows us to connect the measurements of a whale to their performance as they dive. So in this case, we've applied a multi-sensor tag to a humpback whale, and that tag information can then provide us details on the animal movements underwater. So in this case, those tag data are created into a 3-dimensional ribbon plot that provides information on when the animal is fluking, its depth, and its foraging behavior. And now that we have the ability to size these animals, right, through photogrammetry, we're then able to connect up performance of the animals in terms of foraging in relationship to their species, their morphometrics, and their body size and condition. So super helpful to be able to work in these integrative ecology contexts. All right, so finally, we can move on and talk a little bit more about habitat assessments, right? So the nice thing about our flying drones is that whenever we're capturing information about organisms, we're also capturing a lot of information about their environment. And so they're particularly helpful for that. And so the last video that I want to show you here is an example of a study of penguin colonies in a small archipelago in the Antarctic Peninsula region, and how we can use them to do biogeographic assessments of those places. So here we will see the hand launch of a fixed wing drone that's going to set out and map an island with penguin colonies in the Antarctic Peninsula region. So here the aircraft is launched by hand, after which we're going to transition the view to the 3-dimensional data that's collected through structure from motion photogrammetry. So in this case, we get a 3-dimensional model of the island that's geographically rectified and accurate. And it gives us a lot of information, not only about the number of penguins that might be in that location, but also the relationship of their colonies to elevation or other components of the habitat that might be prime factors in driving the locations that they choose and why some colonies persist and others don't. And so this is a really good example of how we can use drone technology to be able to study not just organisms, but the habitat context in 3 dimensions. A very useful and new thing that we can work on. Drones create a lot of different data and large volumes of it. And so that means we're working always to try and develop computer vision and artificial intelligence approaches to be able to help move through them. And some of the things that we're going to touch on in the next few weeks focus in on the use of artificial intelligence, and in particular subsets of that, both machine learning and deep learning, where computers are trained to be able to conduct tasks that humans would do in terms of detecting and differentiating or identifying different habitat components or organisms. So we'll touch on a little bit about that as we move forward, but it's an important factor for us as we deal with the volumes of data that are being created by our drone programs. It's a perfect example that kind of builds on our case for doing photogrammetry and measuring whales. We can actually create computer systems that will take in pictures, identify those species, classify them, and then make their measurements, which can greatly speed up our work when we're collecting large volumes of imagery of whales over time. The last things we're going to touch on are kind of our best practices, rules, and regulations, and a little bit about what's going to happen in the future, right? So we have legal things that are associated with the use of drones in the national airspace, and they vary by country. We also worry about things like animal disturbance or how our activities might affect the environment. And we have to be cognizant of the privacy and security of people that might be working in our study areas. And this kind of gives us some, some things to think about and things to work on as we start to apply these new technologies. For the most part, we know that drones can be disruptive for some animals, but there's very little evidence that large marine species are disturbed by drone flights. We know that sound doesn't propagate well between the air and the water, and in some cases, they're not perceived as a threat. In some cases they are, and in fact sometimes it depends on the configuration of the drone and whether or not it may actually represent something to a species like potentially a predator like a bird of prey. So these things are both platform and species specific, and things that we need to work on as we work towards all of our different projects and thinking about best practices. There are lots of caveats that are associated with using drones, and clearly we have regulatory limitations. In some cases that's about our operations. In the US, we have to fly within a line of sight and not during the night and not over people unless we have specific waivers from the FAA. But there are also other regulatory limitations, including evolving cybersecurity regulations that people have to navigate to be able to effectively use this technology. And finally, when we think about the use of drones, there's a growing interest in using drones to be able to study humans in the context of marine science and conservation. So drones can be used to detect illegal activity, say in a marine protected area. They can be used maybe to support law enforcement action and maybe other things. But these are very interesting topics that are not very well explored, and they probably make you nervous. I think they make everyone nervous. And so these are things that we're going to talk a little bit about a little later on over the next few weeks. So this is our first introduction to how we use drones in marine science and conservation. I hope you enjoyed the video, and I would like to thank you for watching, and we'll see you soon.